All right, non-resident training course, September 1998, Navy Electricity Electronic Training Series, Module 10, Introduction to Wave Propagation, Transmission Lines and Antennas, NAVEDT, RA14182. Distribution Statement A, approved for public release, distribution unlimited. Chapter 1, Wave Propagation. Chapter 2, Radio Wave Propagation. Chapter 3, Principal Transmission Lines. Chapter 4, Antenna. Appendix and Index. Alright, throughout this talks for the course, we will give you the technical manuals associated with with the equipment that you will be working with. You will find below the notations of some of the paragraphs. The notations you have to emphasize with the safety hazards exist and care must be taken and observed. Warning, an operation, procedure, practice, condition, etc., which may result in the injury or death if not carefully observed or followed. Caution, an operation, procedure, practice, condition, etc., which may result in the damage to equipment if not carefully observed or followed. Note, an operation, procedure, practice, condition, etc., which is essential to emphasize. Alright, Chapter 1, Wave Propagation. Learning objectives are stated at the beginning of the easier for the tabs. Learning objectives are the previous information that you expect for the learning chapter. Comprehensive check questions are based on the objectives basic successful completion of the NRTC, indicating that you have met the objective of learning. The information learning objectives are listed below. Upon completion of this chapter, you should be able to state wave motion defined in the terms of reflection, refraction, and diffraction. Describe the Doppler Effect. State with the waves defined with the propagation medium. List and define terms applied with the sound waves, such as cycles, frequencies, wavelength, velocity, and 3 requirements of the sound. Define pitch, intensity, loudness, quality of the application of sound waves. State acoustical effects as echoes, reverberation, resonance, noise having no sound waves. Noise having on sound waves. Describe the light waves and list of characteristics, list of various color light. Define the term reflection, refraction, diffusion, absorption applied to light waves. State the difference between sound waves and light waves. State the electromagnetic wave theory and list of the components of the electromagnetic wave. Introduction. One of the many of the technical subjects of the name of the personnel are expected to know, but probably with one of the least expectable change in the theory of the wave propagation. The base principle enables the wave to be promulgated, transmitted through space at the same time today as whether they were 72 years ago. I would think that they thoroughly understand these principles of relatively simple tasks. For the electrical engineer or individual with a natural curiosity for the unknown is indeed a simple task. Most of the techniques, however, tend to view the wave propagation as something complex and confusing, and would just as soon see the chapter completely disappear from the training manual. The attitude undoubtedly stems from the fact that the wave propagation invisible force that cannot be detected by sense of light, sight, or touch. Understanding wave propagation requires the imagination of the visualizer. The associated concepts, however, they used a practical application of the manual was developed to help you visualize. Understand the concept through the ample of the illustration, step-by-step transition from the simple to complex. Will you have developed better understanding the wave propagation? In this chapter, you will discover the propagation theory of the wave at an introductory level without going through the technical details concerning the engineering. However, you must still use the thought and imagination to understand the new ideas and concepts as they are presented. To understand radio wave propagation, you must first learn the wave propagation. Some of the day basic physics and property of the effect of the propagation. Many of these properties are common every day with occurrences on which you already are familiar with. What is propagation? Early man was quickly recognized with the need to communicate between the range of the human voice to satisfy the need to develop the alternative method of communication, such as hand gestures, beating on a hull of log, smoke signals. Although these methods were effective, they were still greatly limited in their range. Eventually, the range limits were overcome with the development of the courier and postal system, but that was the problem of speed. For centuries, times required the delivery of the message depending on the speed of the horse. During the later part of the 19th century, both distance and time limitations were largely overcome. The invention of the telegraph with possibly instantaneous communication over the long wires. A short time later, a man discovered how to transmit messages in form of radio waves. As you will learn, that this chapter of radio waves are propagated with the propagation means the movement of through medium. This is much easily illustrated with the light ray. If the lights are turned on in the darkened room, the light rays travel through the light bulb through the room. The flashlight is turned on, the light rays also radiate the bulb are focused on into a narrow beam. You can also use the example of the picture of how the radio waves propagate. Like the lit room, radio waves may spread out in all directions. They can also be focused and concentrated with the light of the flashlight, depending upon the need. The radio waves are a form of the radiant energy, similar to the light and the heat, although they can neither be seen nor felt. Their presence can be detected through a use of sensitive measuring device. The speed of both of the waves, both of the forms of the waves, and travel in the same. They both travel in speed and light. All right, you wonder when you can see a light with a radio wave that exhibits the same form of the energy to light with a reason that you can see with what your eyes can detect. Your eyes can detect radiant energy only with a fixed range of frequencies. Since frequencies of the radio waves are below frequencies that your eyes can detect, and you cannot see the radio wave. The theory of wave propagation that discussed the module applied with the Navy electronic equipment, such as radar, navigation, detection, communication equipment. We will also not discover these individual systems modules, but we will explain in the future modules. Them in future modules. Principle of wave motion. All the things of the earth on land or in the water showered continually with a wave of the energy. These waves that simulate they are sensitive can be seen, felt, and heard. For instance, we can see with the light, hear, sound, feel, heat. However, when some of the waves that do not simulate our senses, for example, the radio waves such as the receiver that our portable radio television sets cannot be seen, heard, or felt. The device must be carried with the diverted radio wave into light, the TV picture, sound, audio for the sense of them. A wave can be defined as a disturbance, sound, light, radio wave that moves through of medium, air, water, vacuum. To help understand this is mean the disturbance which move through the medium. Picture for the following illustration. You're standing in the middle of the wheat field. As the wind blows across the field towards you, you can see the wheat stalks bending and rising of the force when the wind moves into the crop of the window. The wheat appears to move toward you, but is instead of the stalks that actually move back and forth. You can see that the medium in the illustration is the wheat, and the disturbance of the winding move. The wind moving in the stalks of the wheat. Wave motion is defined with a recurring disturbance avoidance through the space with and without the physical medium. Wave motion, therefore, is means of moving and transforming energy one point to another. For example, when sound waves strike a microphone, sound energy converted with the electrical energy limit. Like when light waves strike a phototransistor or radio waves strike an antenna, they are likely converted with electrical energy. Therefore, the sound, light, and radio waves are all forms of energy that move in wave motion. We'll discuss the sound wave, light waves, and radio waves later. Wave motion and water. Type of the wave motion familiar with almost every one of the movement is wave in water. We'll explain what they use waves at first for the happen to understand what the wave motion in terms as described it. Used to describe the basic wave motion shown in dropping the stone in a pool of water. After the stone enters the water, the surface distribution is created as a result of an expanded circuit, series of the circular wave, the figure 1-2, the diagram and the action view. A show the falling of the stone of the instant because of the force strike of the water. View B show the action of the taking place at the instant of the stone strikes the surface. The pushing of the water there is around the upward and outward view. C, the stone shows sunk deeper in the water, which have the closest violently over, causing some spread with the leading of the wave that has moved outward. An instant later, the stone has sunk out of sight, leaving the water disturbed, as shown view D, leading the wave that's continued moving outward, followed by a series of waves gradually diminishing in amplitude beyond. Meanwhile, disturbance original point of the contact has gradually subsided. 1-1 formation wave forms. Surface of water, falling stone, leaving the waveform. Stone strikes water, leaving wave moves outward, sprays, partial original distance, leading wave. In the example, the water is not actually being moved outward. The motion of the waves builds up and down. Waves move outward. The upward motion, down motion, is transverse right angle through the outer motion of the wave. The type of the wave motion is called transverse wave motion. All right, transverse wave. To explain transverse waves, we again use our example of the wave water wave with the figure 1-3 with the cross of the sectional diagram of the wave view for the side of the nose for the wave with the succession of the crest of the trough of the wavelength of the 360 degrees for the distance of the crescent of the one wave of the crest of the next. Between the two similar points of the adjacent wave of the amplitude transverse wave that will have the distance measured vertically from the crest of the trough of the water waves known as the transverse wave become the motion of the waters up and down with the right angle of the direction which of the moves and traveling with this obeying of the clock, cork bobbing up and down on the water waves pass through the cork moving the very slightly in the sideways direction. In figure 1-4, the small arrows show up and down with the direction of the cork move of the transverse wave and then set in motion the direction the wave travels and shown with the large arrow radio wave, light waves, and heat waves example of the transverse waves. Figure 1-3 shows the general elements of the wave, amplitude, wavelength, trough, and crest. Transverse wave, direction of the motion wave travel, longitudinal waves. In the previous discussion, we listed radio waves, light waves, heat waves. Example of the transverse wave. We did not mention sound waves. Simply because of the sound waves that are longitudinal wave, the transverse waves, which travel in the right angle with the direction of the propagation. Sound waves travel back and forth in the same direction, wave motion. Therefore, longitudinal waves are waves, and the disturbance take place in the direction of propagation. Longitudinal waves are sometimes called compression waves. Waves make up the sound with such as those of the setup of the vibrating tuning fork. A longitudinal wave of the figure 1-5 of the tuning fork will struck with the setup of the vibrations at the time tin moves in and outward direction. They move, the tune moves in and out. The tin are moves outward in direction immediately in front of the compressor, made more dense, and so that its monetary press of the pressure is raised above the other points of the sound medium air. Because of the air is elastic, the distribution transmitted with the outward direction of the compression wave. The time returned to the move with the inward direction within the air front of the time is referred to as made less dense with expanded, so that the pressure is lowered below the other points of the sound surrounding air. The ratified wave is propagated with the tuning fork allowed the compressed wave through the medium air. All right, tuning fork times parallel rarefield compress. All right, medium. When you have used the medium to describe the motion of the wave of the medium of the term that is used frequently discussing propagation, needed to be defined. We understand the medium is the application for the propagation. Medium of the vehicle through the width of the wave travel from one point to the next. The vehicle will carry the wave because can be just about anything. For example, I already mentioned that air is defined in the dictionary is a mixture of the invisible, orderless, tasteless gas sounds of the earth. The atmosphere, air is made of the molecules, various gases, impurities. We will call these molecules the particle of the air and simple particles. Figure 1.6 will help you understand how waves travel through air. The object producing the wave that is called the source of the bell is an illustration. The object responding to the wave is called the direct detector receiver. In this case, of the human ear, the medium is air, which is mean for the conveying the wave. The source of the detector, sound detector, medium are all necessary for wave motion and propagation, except for the electromagnets, which require no medium. Waves shown in Figure 1.6 are sound waves. The bell is rung with a particular air around the bell or compressed, and then expand with the compression, expands in with the particles of the air. Set up the wave with the motion of the air. Motion in the air. The waves are produced that carries the energy of the particle through the medium and air to the detector ear. Figure 1.6 shows the three elements of the sound waves: medium, air, detector, ear, source, bell. Terms used in wave motion. The number of the special terms concerning the wave that you should know. The many of the terms are cycle, wavelength, amplitude, frequency were introduced in the previous Neets model. Will not discover the terms as they pertain to the wave propagation before we begin our discussion. However, note that in fact, figure wave 1 and wave 2 have the equal frequency. Wavelength must be but different amplitudes. Reference line, also known as the rest position or point of zero displacement, in this place for the particular matter would have that if it were not disturbed by the wave motion. For example, in the case of the water wave, the reference line is level with water. No motion is present. When in this line, let's go on a discussion of four terms shown in Figure 1.7. 1.7 is a comparison of differential amplitudes. Amplitude, top of the crest cycle, bottom of the trough, wavelength, amplitude, site 1 cycle, reference line. Alright, cycle. Refer to the wave 1 with the figure 1 with the note for how similar with the same wave that you've already studied. All the transverse waves appear as the same wave that you within from the side of the figure. 1/7 wave is 4 complete cycles. Point A, B, C, D, E comprise one complete cycle having missing button value above the maximum value below the reference portion above the reference line point between points A and C that is called the positive alteration portion below the reference point between points C and E is known as negative alteration. The combination of one complete positive, one complete negative alteration represents one cycle of the wave. At point E, the wave begins to repeat itself with the second cycle to complete with the point I, the third point M, etc. The positive on the peak of the positive alteration maximum value of the above the line is sometimes referred to as the top of the crest. Peak through negative alteration maximum value below the sometimes called bottom trough, as depicted in the figure. Therefore, one cycle has one crest, one trough. Wavelength is a distance in space occupied with one cycle of the radio wave. Then, given the instant of the wave could be frozen in place, the measure of the wavelength would be in the distance from the leading edge of the one cycle corresponding with the point of the next cycle. Wavelengths vary with a few hundredths of an inch. Extremely high frequency of the many mild, extremely low frequencies. However, the common practice is to express wavelengths in meter. Therefore, figure 1/7 of the wave 1, distance between A and E and B and F, and it's one wavelength. The Greek letter lambda is used to signify wavelength. Lambda is not IRL. This is the L you conventionally add the symbol for the inductance, and I the dimension I used for dimension length. L is conventionally used in the symbol of inductance, and I is in the dimension length. Therefore, lambda is indicated with the length of waves. Amplitude. Two waves may have the same wavelength, with the crest of the one may rise higher than above the reference line with the crest of the other. Compare the wave 1, wave 2 on figure 1/7. Again, the height of the wave of the crest above the reference line is called the amplitude of the wave. The amplitude of the wave gives the relative indication amount of the energy of the wave train. Then it's continuous series wave at the stretch of the A through Q having sample amplitude wave length, which is called the train wave of the wave train. Or your frequency and time. Time is an important factor of the wave type of the wave train passing for the medium of a certain number of the individuals path of the point over the specific unit type. For example, the cork on the water rises, flows once every second of the wave, makes one complete up and down vibration every second, and the number of the vibration. The cycle of the wave of the train with the unit time called the frequency of the wave of the train is measured in hertz. If 5 waves pass a point in one cycle, the frequency of the wave train is 5 cycles per second, and in figure 1/7 of the frequency of both wave 1 and wave 2, 4 cycles per second. Cycles per second is abbreviated as CPS. In 1967, in honor of the German physicist Heinrich Hertz, the term Hertz was designated for use of the loop with the term cycles per second, referring to the frequency of the radio wave. That many seems confusing with one place the term cycle was used to designate the thought of the negative alteration of the wave, but in another instance, the Hertz is used to designate the appears to be same thing. The key is the time factor of the time cycle is any of the sequence events such as positive and negative alteration comprising with one cycle electrical current term. Hertz refers to the number of occurrences that take place in 1 second. The characteristic of the wave motion. Alright, two types of the wave motion, transverse longitude. How many of the same characteristics, frequency, amplitude, wavelength? Important characteristics for these two types of the wave motion share the velocity of propagation, and the rate of the disturbance traveled through the medium velocity in which the crest of the wave moves along. Velocity of the wave depends on the type of the wave, light, sound, radio, type of the medium, air, water, metal. In longitude of wave, the plotted as a graph there is a transverse wave. The fact is illustrated in figure 1.8. 1/8 of the longitudinal wave represented with the graphically in a transverse wave. Amplitude, wavelength. The frequency of the longitudinal wave like that of transverse wave, number of the complete cycle of which make with it during a specific unit time, higher frequency with the greater the number of the expression capacity per unit. There are two types of the wave motion described in the preceding discussion. The following quantities are interest. The period is which is the time for which one completes some vibratory cycles events occurs. Frequency or vibration, which is the number of cycles taking place in 1 second of wavelength of the distance of the disturbance traveling during one period of the vibration. Now consider the following concept. The vibration object with a certain number of the vibrations per second. The 1 second divided by the number of the vibrations equal to the period of the time of one vibration. In other words, the period of the time one vibration is a reciprocal of the frequency. Thus, the time of one vibration is equal to 1 over the frequency, or time is equal to 1 over the frequency. Now that you have the value of the velocity of the wave, you can determine the wavelength dividing the velocity of the frequency as an equation. Or the wavelength is equal to the velocity of the propagation over the frequency of the vibration. When you use the above equation to carefully express the velocity wavelength with the proper unit of length, for example, the English system, the velocity expressed in feet per second divided by the frequency expressed in cycles per second, or hertz wavelength is given in feet per cycle. If the metric system is used with the velocity expressed in meters per second and divided by the frequencies expressed in cycles per second, the wavelength is given in meters per cycle. Be sure to express both of the wavelength and the frequency in the same units. Feet per cycle with the meters per cycle are normally abbreviated as feet meters because of the wavelength indicates 1 cycle. Because the correlation holds true for both the transverse longitudinal wave, the U of the study with the electromagnetic wave and sound waves. Conduct the following example. 2 cycle of the wave fixed in every second with fixed point every second, and wave velocity of the wave train is 4 feet per second. The wavelength of the formula to determine the wavelength is as follows. Wavelength is equal to the velocity of the feet per second or times the frequency. 4 feet per second over the frequency is a 4 feet per second at 2 hertz. It's 2 feet. No other problems in this kind. Be sure to not confuse the wave velocity with frequency. Frequency, the number of cycles per unit of time. Wave velocity is the speed at which the wave trains pass a fixed point. Here's another problem. If the velocity of the 1100 feet with per second, the wavelength of the 30 feet with the frequency of the wave. The transposing general question frequency is equal to the velocity over the wavelength in feet. So you'd have 1100 feet over 30 feet would give you 36.67 hertz. To define the velocity, rewrite the equation, or velocity of the 1100 feet is equal to the wavelength in feet times the frequency in hertz. Alright, so you'd have the, let's work on one problem at a time. You have the metric system. Some of the wavelength is 0.4 meter. Frequency is 12 kilohertz. What is the velocity of the formula? Velocity is equal to wavelength times the frequency. Wavelength is 0.4 meters times the frequency of 12 kilohertz would equal to 48,000 meters per second. Are there other important characters of the wave motion of the reflection, refraction, diffraction, Doppler effect with the big words for the concept of the E for the to U for the ease for the understanding? We'll explain the two characters for the light wave, the last two characters for the sound wave. You should keep in mind that all the waves react in a similar manner when mediums such as air, solids, gases, waves travel in a straight line. When the wave leaves the boundary one medium and enters the boundary of a different medium, the wave change with the direction for the other purpose of the module boundary is imaginary line separate to one medium and another. When waves pass with the one medium can encounter for the medium that have the different character, three things can occur to the wave. Some of the energy is reflected back into the initial medium. Some of the energy is transmitted to the second medium, which will continue at a different velocity. And three, some of the energy can be absorbed by the medium. And in some cases, all three processes, reflection, transmission, absorption, may occur to some degree. Reflection waves are a simple wave that are neither transmitted nor absorbed, but are reflected from the surface of the medium of the encounter. If the wave is directed again for the reflecting surface of the mirror, it will reflect the bounds of the mirror. The referred figure 1.9 of the wave directed toward the surface of the mirror is called an incandescent wave. When the wave bounces off the mirror, it becomes known as the reflected wave of an imaginary line perpendicular with the point of which the incandescent wave travels the mirror surface of the normal perpendicular. The angle between the incident wave and the normal is called the angle of the incident. The angle between the reflected wave and the normal is called the angle of the reflection. Alright, figure 1.9 shows the reflection of the wave, the reflecting surface of the incident wave, the angle of the incident of the normal, or the angle of the reflection wave perpendicular. Also, the reflecting surface is smooth, polished, and the angle between the incandescent ray and the normal will be same as the angle between the reflected ray and the normal. Conforms the law of the reflection with the state of the angle and incident of the equal of the angle of the reflection. The angle of the amount of the indicator incident wave of energy reflected with the given surface depends on the nature of the surface, the angle of which the wave shake. The surface of the angle incandescent increases the amount of the wave of entry. Reflected increases the reflected energy of the greatest wave of the narrowly parallel with the reflecting surface with the incident wave that is perpendicular in the surface. More of the energy is transmitted in substance than is less reflected. The incident angle of the mirror reflects almost all the wave energy, while the dull black surface reflects very little. Alright, refraction. When a wave passes from one medium to another with a different velocity of the propagation change of the direction wave, will occur the change of the direction wave of the inch of the sound. Second medium called refraction. Of a discussion of refraction wave of the description striking a boundary surface is called the incidental wave. The imaginary line perpendicular with the boundary is called the norm. The angle between the incident wave and the normal is called the angle of the incident. The wave of the path of the boundary either toward or away from the normal. The angle between the normal and the path of the wave through the second medium is called the angle of the refraction. A light passes through the block of the glass. I'm showing figure 110 of the move to point A to point B with a constant speed. This is the incident wave of the wave penetrating the glass boundary with the point B of the velocity of the wave. It is slowed down when the cover of the wave depending with the torque of the normal. The wave then takes place with the point B and C with the glass in both the reflected wave at the top of the surface of the incidental wave. The lower surface of the wave passes through the gas in the air of the second boundary. It's again refractive at the time of the wave from the normal takes the path of the point C into the D. As the wave passes through the last boundary, the velocity increases the original velocity. Figure 110 shows the refracted wave that can be bent toward and away from the normal. Depends on the velocity of the wave through each medium. The broken line between the points B and E of the path of the wave travel through the two mediums of air and glass for the same density. Alright, 1/10 shows the refraction of the wave medium more than dense air or glass. Incident wave, the norm, and also your normal refracted ray. To summarize the figure 110, if the wave path of the less density of the medium, the more dense the medium, the event toward the normal, the angle of refraction is left with the angle incident. If the water is more dense, the less for the less dense medium, the bend away from the normal, the angle of refraction is greater than the angle of the incident. You can more easily understand the refraction of the looking at figure 11 the plow field of the middle of the parade ground. Think of the incident of the accompanying recruiters marching of the fourth abreast of the angle across the parade ground. Plowed field crossing the plowed field, coming out over the other side of the parade ground again. As recruiters march diagonally across the parade ground, beginning to cross the boundary and plow into a plow field. Front line slow down because the recruiters arrive at the boundary at the different times. They will begin to slow down at different times. Number 1 slows down first, and number 4 slows down last in each line. The net effect of the bending action that when the recruiter leaves the plowed field, the recruit re-enter the parade ground and reverse action is taking place. Figure 111, the analogy of the refraction, parade ground, plowed field, parade ground, diffraction. Or diffraction is the bending of the wave path when the wave's bent due to met an obstruction. The amount of the diffraction depends on the wavelength of the wave. The high frequency of the wave is rarely diffracted and diffracted in a normal world that surrounds us. Some light waves or high frequency waves are rarely see light diffracted. You can have they observe the diffraction sound waves by listening to music. Suppose you're outdoors listening to a band and it steps behind with a solid obstruction such as a brick wall. You will hear the mostly low notes. This is because of the higher notes that having the short wavelengths undergo little or no diffraction paths over the wall without wrapping around the wall, reaching the ears. Those low notes having longer wavelengths wrap around the wall and reach your ears. The leads to the general statement of the lower frequency wave tends to diffract more than high frequency wave of the broadcast band. AM radio waves, low frequency waves often travel over a mountain or opposite side from the Earth's surface because of the diffraction, while the higher frequency of the TV and FM waves signals from same source tend to be stopped by the mountain. Alright, Doppler Effect. The last but equally important characteristic of the wave will be discovered the Doppler Effect. The Doppler Effect is a apparent change in the frequency of pitch which sound of the source of the move either toward or away from the listener. When the listener moves, it's either toward or away from the sound of the source of the principle discovered the Australian physicist Christian Doppler applied to all wave motion. The apparent change of the frequency between the source of the wave, receiver of the wave, is because of the relative of the motion between the source of the receiver. To understand the Doppler Effect, first assume that the frequency of the sound from the source is held constant. The wavelength of the sound will remain constant. If both the source and the receiver of the sound remain stationary, the receiver will have same frequency sound produced in sound produced by the source. This is because the receiver is the same of the number of the waves per second when the source of the producing. No, if either the source of the receiver both will move toward the other, the receiver will perceive the higher frequency sound. This is because the receiver will receive the greater number of the sound waves per second and interpret the greater number of the waves as a higher frequency sound. Conversely, the sound and the receiver are moving apart. The receiver will receive the smaller number of the sound waves per second that will receive the lower frequency sound. In both cases, the frequency sound produced and source will have to remain constant. For example, the frequency of the whistle of fast-moving train sound with increasingly higher and the pitch of the train approaching with the train and part with it. But although the whistling generated sound wave with the constant frequency with the travel through the same velocity in all the directions, distance between the approaching train and listener decreasing as a result. Each of the wave that has less distance traveled to reach of the observer of the wave preceding it. Thus, the waves arrive will decrease intervals of time between them. The apparent frequency of the call for the Doppler effect of the operation of the equipment, the effect of the measuring at wave energy, the detail of electromagnetic wave propagation, and the Doppler principle issue of the equipment, such as radar target detection, weapons control, navigation, and sonar. Alright, sound waves. To study sound is important because of the role sounds play for the definite finding. Equipment that fathometer underwater detection. Equipment that sonar as you know, the sound travels through the medium of the wave motion. Although sound wave and the electromagnetic waves the propagation of the radio differ both in types of wave that have many of the same characteristics. The study of the principle of sound wave motion will help you to understand the difference of the both sound wave and the more complex radar, electromagnetic wave. The more differences among the sound wave, the heat wave, and the light waves are the frequency, their types, and the mediums of which they travel, the velocity with which they travel. The sound, what is it? The word sound is used every day with speech with the signify the variety of things. One definition of the sound is the sensation of the hearing, and another definition refers to stimulus capable of producing sensation of the ear. A third definition limited to sound is actually heard by the human ear. Study of this sound with a defined origin is range of compression wave, the frequencies at which the human ear is sensitive. The purpose of the chapter, however, the broadband definition of the sound to include the compression wave that is not able to, not always audible to the human ear. To distinguish the frequencies audible range from these outside of the range, where the words sonic, ultrasonic, and infrasonic are used. The some capable of being heard with the human ear are called sonics. Their normal hearing range extends from 20 to 20,000 hertz. However, the established standard sonic range through the Navy are attributed upper limits of the sound sonics of 10,000 hertz or lower limits of 15 hertz. Even though the average person can hear sounds above 10,000 hertz, in a standard practice referred to the sound above the frequency as ultrasonics. Sounds between 15 hertz and 10,000 hertz are called sonics, while the sounds between 15 hertz and below 15 hertz are known as infrasonics, formerly referred to as subsonic sounds. Or requirements for sound. Recall the sound wave, the compression wave, the existing compression wave that depends on the transfer of the energy produced. The vibration becomes the sound. Mechanical device the source must first receive the input energy. The next device must be in contact with the medium. Will receive the sound energy carried with the receiver. If the device is not in contact with the medium, the energy will not be transformed to the receiver. There will be no sound. The three basic elements of transmission reception of the sound must be present before the sound can be produced. That's the source of the transmitter, the medium of the carrying the sound, air, water, and metal, with the detector or the receiver. A simple experiment provided with the convincing evidence if the medium must be present if the sound is to be transformed. Figure 11 and 12 of the electrical bell suspended with a rubber bandage bell jar with the air can be removed. The external switch is connected with the battery to the bell so that the bell will run intermittently as the air is pumped out. The sound of the bell becomes weaker and weaker. If the perfect vacuum can be obtained, no sound will be conducted out of the jar by the rubber bands. If the sound from the bell was completely inaudible, with the other words, some sound cannot be transmitted through the vacuum. When the air is emitted, the sound was loud as was it began. The experiment showed that the air is contact with the vibrating bell. It covered the energy, the walls of the jar. Walls of the jar, which in the turn are set in the vibration, thus the energy path of the air outside of the jar, then onto the ear of the observer. The experiment illustrated that the sound cannot exist in empty space or on vacuum. Show the 1-2-12 there is no air, no sound. Rubber bands, push, pull, switch, vacuum, pump. Any object more rapidly back and forth vibrates, disturb the medium around it, may consider the sound bells, speakers, stringed instruments, family sound, and sources. The material which the sound traveled was called the medium. The distance of the density of the medium determined the i.e. the distance and speed of the sound transmission. The higher density of the medium, the slower the sound traveled through it. The detector acts as the receiver of the sound wave. The couple does not surround the surface of the sound wave. The detector absorbs the only part of the energy of this wave that is sometimes required the amplifier boost of the weak signal. An illustration of what happens with one of the three elements is not present. But let's refer to the experiment which with the bell has been placed within the jar containing the vacuum. You can see that the bell struck with the beat. You can hear no sound because of the no medium. The transit sound from the bell to you to know. Let's look, for example, the third element. The detector is missing. You can see the source of the explosion apparently producing the sound. You know the medium that are present, but you are far away to hear the noise. Thus, as far as you are concerned with the no detector, therefore no sounding, will assume that the sound can exist on the only transmit the sound through the medium in which the path of the detector, therefore in the absence of the on over the basic element source or medium detector, there could be no sound. Turns you in the sound wave, the length of the accordance with the higher frequency sound having a long wavelength is the low pitch with the low frequency. One short wavelength is heard with a high pitch with a high frequency. The complete wavelength is called the cycle distance of the one point of the wave corresponding point. The next wave is called the wavelength. The number of cycles per second in hertz and frequency of the sound. But the frequency of the sound is also the number of the vibrations per second by sound source. Characteristics of sound. Sound wave is traveled in great distance in a very short time. The body distance increases the wave of the tends to spread out. The sound wave spread out with the energy simultaneously spreads down. The increase of the large area. The wave of the energy becomes the weaken the distance from the sources. The increased sounds are broadly classified in two general types. Groups. One group is noise, which includes the such sounds pounding of the hammer slamming of the door. Other group is musical sounds or tone. The distinct between the noise and tone of the based on the regulatory of the vibrations, the degree of the dampening ability of the ear to recognize the components have with the musical sequence. You can best understand the physical difference between the kinds of the sound by comparing the wave shape of the musical note depicted in view A, figure 113, the wave shape of the noise shown in view B. You can see the comparison of the two wave shape of the noise that makes an irregular and haphazard curve, and the musical note makes a uniform regular curve. Musical noise. Sound has three basic characteristics: the pitch, sense, and quality. Pitch, intensity, quality. Each of these three characteristics is associated with the property shown over the type of the waves which are produced. The pitch depends on the frequency of the wave. The intensity depends on the amplitude of the wave, and the quality depends on the form of the wave. The proper combination of these characteristics, the tone is pleasant to the ear, with the wrong combination of the sound and quality, it turns to noise. All right, pitch of the sound. The term that's the pitch of the describes the frequency of the sound and object that vibrates many times per second. The practice produce the sound with a high pitch, while the police whistle slow vibration, the heavier of the string of the violin causes the low pitch sound. With the high frequency of the wave that determines the pitch. When the frequency is low, sound waves are long, which are high with the wave, or short with the sound can be so high, and the frequency of the waves reaching the ear cannot be heard. Likewise, such frequencies are so low that the eardrums do not convert them into sound. The range of the sound of the human ear can detect vary for each of the individual. Or intensity of the sound. Intensity of the sound is a completely different. Depends on the amplitude of the wave, the tuning of the force, go into more energy of the form of the sound of the striking. Hard when the struck gently, but you should remember the tuning fork is struck with the sound of the omnidirectional heard in all directions because of the sound wave spreads out in all directions. Figure 114. You can see the figure of the distance between the wave and the sound increases the energy in which the spreads over the greater area of the hence the intensity of the sound, the creep of the speaking tube, sometimes you the board, shift rather than the sound wave from the spinning of all direction, concentrating them in one desired direction, unidirectional, producing greater intensity. Therefore, the sound is heard almost with the original intensity, the opposite end with the speaking tube. You need your unidirectional megaphone with a directional loudspeaker to prevent sound wave from spreading in all directions. 4/14 of the sound wave spread in all directions. Sound intensity loudness often mistaken and interpreted with having the same meaning, although they are related. They are not the same. The sum of the intensity measured for the sound energy of the wave of the loudness. On the other hand, the intensity of the sensation of the intensity, sometimes the frequency of the sound wave produced on the air. The increasing the intensity coupled with the increase of the loudness, but not in direct proportion. For distance, the doubling the loudness of the sound requires the tenfold increase of the intensity of the sound. Sound quality. Most sounds, including musical notes, that use pure note. The mixture of the different frequency tone of the tuning fork will struck with the produce of the pure tone with a specific frequency. The pure tone is produced with the regular vibration. So with the timing of the tuning fork, on the other hand, scraping the your fingernails across the blackboard only creates noise because of the vibration of the regular. Each of the individual pipe of the pipe organ is similar to the tuning fork. Each pipe produces the tone specifically with frequency for the sounding. With the two or more pipe of the same type that produce the complex waveform, the tone of the complete, close, intimate, any type of the vowel sounds can be produced. Selecting the proper pipe, sounding them at the same time. The figure 11 to 15 illustrate the two pure tones to a complex wave. Tone A, tone B, resonant tone C. The quality of the sound depends on the complexity of the sound wave, such as the wave shown in the tone C of the figure 115. Almost all the sound, musical and vocal, included have been completed complex. Waveform touch tone A, the simple wave of the specific frequency can be produced with the tuning fork of the piano, organ, or musical instrument. Tone B, the simple wave of the different frequency that when two tones are sounded together, the complex waveform of the tone C is produced. Note that the tone C has the same frequency of the tone in which the increase of the amplitude of human ear can be easily distinguished between tone A and tone C. If we cover the quality, therefore, we can see that the quality distinguishes the tone over the pitch, loudness, and sound of the different type of the music instrument. This and distinguishes the voice of the different different persons. Elasticity, density, velocity of the transmission sound wave through the medium, the velocity, the control of the medium, the verifying with the frequency, intensity of the sound waves will not affect with the speed of the propagation. Elasticity, density, the medium, are the two basic physical properties given the velocity of the sound through the medium. And elasticity of the ability to strain body to recover the shape of the deformation as a vibration compression with the measure of the elasticity bound to the forces equal exerted to return original shape. The density, medium, the substance of mass or unit volume of the medium, substance of resistance. Raising temperature of the medium will increase the density with the effect of the increase of the velocity of the sound of the medium. Velocity of the sound is elasticity is expressed as velocity is equal to the velocity over the density square, the square of the velocity over the density. Elasticity over the density. Velocity is equal to the square root of the elasticity over the density. Alright, even though the solids such as steel, glass, are far more dense than either the elastics are such the greater the velocity sound with the 15 times greater the velocity sound in the air, the elasticity rough indication speed of the sound given the medium. We can see that stay with the general rule of the sound travel faster with the harder materials such as steel, slower and liquid slower than gases. Density is how opposite of the effect of the velocity of the sound with the other factors constant. The denser the material such as the lead passes the sound slower. At a given temperature, atmospheric pressure, always sound waves travel in air with the same speed with the velocity sound will travel at 32 degrees Fahrenheit at 1,087 feet per second. But for practical purposes, the speed of sound of the air is considered 1,100 feet per second. Table 1.1 give the comparison of velocity sound of various mediums. All right, you have air, aluminum, carbon, fresh water, hydrogen, lead, salt water, steel. All right, acoustics. The sound of the sound, the science of the sound is called acoustics. The subject of it is called the fill of the volume of the technical books. But we'll only scratch the surface of the chapter. Will present important points that you will need to be understand with the sound wave. The acoustics, like sound waves, relate with the same sense of the hearing, a deal with the production, control of the transmission, reception, and effect of the sound. For the present, we are concerned only with the last relationship with the effect of the sound. The same effect will be through your study of the waves. Echo. An echo is a reflection of the original sound wave that bounces off the distance. If the surface just the rubber ball bounces back through the against the head. Hard surface of the sound waves are bounced off of the most of the surface is learned, but the study of the law of the conservation energy the rubber ball never bounces back as with as much energy the initial bounce. Similar with the reflected sound waves, not as loud as the original sound wave, but in both cases, some of the energy absorbed the reflecting surface. The only portion of original sound is reflected. Only portion of the reflected sound returned to the listener for the reason the echo is never loud as the original sound. Sound reflections, echoes may have application for the Navy. The most important of these applications can be found in the depth finding of the equipment. There are fathometer and sonar. The fathometer sends the sound wave pulse to the bottom of the ship that will receive the echo of the ocean floor, indicating the depth of the ocean beneath the ship. The solar transmit the polar pulse for the sound energy for the receive the echo, indicating the range of and bearing object for the targeting the ocean depths. Alright, refraction. When sound waves traveling in a different velocity pass obliquely at an angle with one medium and the end of the other, the waves are refractive at the line with the travel of the refraction occurs gradually when the one part of the sound is traveling faster than the other parts. For example, a few feet above the surface of the earth, a greater velocity than near the surface of the room. Cover the friction retard the lower layer of the velocity of the wind is added with the velocity of the sound through the air. The result of the upper portion of the sound waves move faster than the lower portion, called the gradual change of the direction of the travel of the wave. Refraction causes the sound with the travel farther than the wind and against it. The figure 116 shows the refraction of the sound of the earth's surface, the reverberation. In an empty room, the other confined surface, the sounds may be reflected several times to cover the known as reverberation. Reverberation, multiple reflection of sound with reverberation, such as a prolonged time of the during with one sound is heard. Example is often occurring in nature with the instant of the discharge of the lightning of the call with the sharp, quick sound. By the time of the sound with the reach of the ear of the distance, or whether it is usually drawn until it is prolonged with the roar of the reverberations, will call with the thunder. With similar call with the often arrived with the underwater sound. Equivalent to reverberations are nearby points that may continue such long and interfere with the returning echo of the target. Interference. Any disturbance made man-made natural that cover the undesirable response to degradation of the wave that is referred to as interference. The two sound wave that move simultaneously through the same wave medium will independently each producing disturbance in either other were not present when the two waves having the same frequency in the favor of each other, moving in the same direction. The additive and or said that they interfere constructively. Two waves have the same frequency and moving the same with the direction out of favor with each other. They are subtractive. Subtractive instead of interfere with destructively. If the two subtractive waves have each equal amplitudes, the waves can cancel each other out, and additional subtraction waves are often called interferences. Or resonance. At some time during your life, you'll probably observe someone putting on his or her head in an empty barrel with the other cavity, making the noise vary in the pitch. When the person reaches within a certain of the pitch of the produced seems much louder than the other, the region of the phenomenon is a certain pitch of the frequency vibration of the voice is matched to the resonant natural frequency of the cavity. The resonant frequency of the cavity body will begin to vibrate, create the sound wave. The resonant frequency of the cavity will reach in the sound, but the relation of the refrain reinforced with the sound waves created with the cavity, resulting in a louder tone. The phenomenon occurs with the frequency of vibration, same with the natural frequency of the cavity, is called resonancy. Noise. The most complex sound wave that produces the noise has no total quantity. They distract with the distort with the sound quantity intended to be heard. The noise is generally unwanted. The disturbance is called the series wave of the originating man-made natural sort of the jet breaking sound of the barrier than the thunder waves or thunder. Alright, light waves. The tactical maintain equipment of the frequency, one end of the electromagnetic spectrum, and then the other the low frequency radio wave, high frequency X-ray, the cosmetic, visible light with a small, but very important for the electromagnetic spectrum. Most important part of the important terms pertain to the behavior of the waves, such as reflection, refraction, diffraction. We discussed earlier in the chapter. We'll now discover those terms that you begin understanding light and light wave. The relation between light and light waves are in the same with the sound and the sound waves. Light informs forms energy with the produced various means, mechanical, electrical, chemical, and as you can see with the above. Because the light rays give off the reflective of the reach our eye. The object that's called the light energy, called the luminance. The other is the object of the score of the light that reflected as it's called illuminated body. Alright, propagation of light. The exact nature of the light is not fully understood, although the scientists have been studied the subject for the centuries. Some of the examples seem to show the light with the component of the tiny particles. Some of this suggest they're made of waves. One theory to another attracted the approval of the acceptance of physics exists today. Some of the scientific phenomena can be made explained only by the wave theory, others only by particle theory. Physicists constantly stretching for the new discovery would bring these two theories in agreement that gradually they come in and accept that their theory that combines the principle of the two theories. According to the very view of the no general accepted with the light forms electromagnetic radiation, and the light with a similar form of the radiation are made of the move and the electronic magnetic field. The two fields will be explained through later in this chapter. Electromagnetic light theory of light. James Carl Maxwell, the brilliant Scottish scientist of the middle 19th century, showed the construction of an oscillating electrical circuit with electromagnetic wave that can move the empty space of the light, eventually was provided with electromagnetic. Current light theory states that light is made up of a very small packet of electromagnetic energy called photons. Smallest unit of the radiant energy of the photons move at the constant speed of the medium through the travel. The photons move at a faster speed through the vacuum. That they do not leave the atmosphere. The slower speed with the water and then the air. The electromagnetic energy of the light is formed with electromagnetic radiation. Light or similar form of the radiation made up of the moving electromagnetic force. Move with the wave of the electron. Move the wave of the matter. Similar to the wave produced the pebble, the drop, and the pool water. Discussed earlier in the chapter, the transverse wave of the light source with the speed spread out with expanding the circle of the light of the wave in the pool. However, the waves in the pool with very small, slow and clumsy comparison of the light will travel approximately 186,000 miles per second. Light radiates in source all direction until observed is diverted with some substance in figure 117. Light drawn with the light source of the light bulb. At an instant, at any point with one of these will indicate the direction of the wave of the or move. The lines are called radii or set over the sphere, and also form the waves are called light rays. Light waves and wave fronts. Although the sin wave of light does not exhibit the light waves, light rays are illustration of conventional method used for showing the direction of the light and traveling at a point. Any point. Our large volume of light can be called the beam. The arrow beam is called the pencil. The smallest portion of the pencil is called the light ray. The ray of light illustrated in the straight line with a straight line drawn with the form of light sort of representing the infinite number of the rays radiating in all directions from the source. The frequency of the wavelengths compared to the sound wave, the frequency of the light waves are very high. Wavelength is very short. These measure wavelength with the most conveniently special unit measure called an angstrom unit. Usually an angstrom was devised in another common unit to measure these waves of the multi-micron using 1 millionth of a millimeter with a micro or 1 microfarad equals 10 angstroms. 1 angstrom is equal to 1055 times the negative 10th m's. Frequency and color. For the description of the light wave that you will, the millimicron measurement of the wavelength of the light determine the color of the light with the 118 indicate the light with the wavelength of 700 millimicrons of red, the light with the wavelength of 500 millimicrons blue and green. They illustrate that show the approximate wavelength of the different color of the visible spectrum. The actual fact of the color of the light depends on the frequency, not its wavelength. However, the light is measured in waves. Figure 118 shows the screen of the slit with a emitting ray of the sunlight, with prism, and then red, orange, yellow, green, blue, indigo, violet, ground, glass, invisible. Where the wavelength of the 700 microns measured for the medium of the such for the air is produced for the color of the bit red, but the same wave that reduced the different medium that have the different wavelength of the red light, which have been traveling air into the grass and lost with feed. Wavelength becomes shorter and compressed, but is continued to be red. The illustration of the color light depends on the frequency, not on the wavelength. The color scale of figure 118 is based on the wavelengths in air. When the beam of the white light with the sunlight is passed through the prism is shown in figure 118 with the refracted dispersed with the phenomenon is known as dispersion until the component of the wavelength. Each wavelength covers a different reaction with the eye, which receive the various colors of the visible spectrum. Visible spectrum is recorded as a mixture of the red, orange, yellow, green, blue, indigo, and violet lights. Result of the primaries red, green, and blue, and are mixed together with the overlapping beam light. There's no primaries of the mixing pigments such as paint. Furthermore, the complementary secondary colors magnesia, yellow, and cyan may be shown with equal easy and mixing any two primary color of the overlapping beam of light. Thus, red and green limited equal intensity will make the yellow light, but green or blue will produce cyan or blue-green light. Blue-red correctly mixed will produce purple reddish light. Light and color. Objects absorb the light with a pulse on them. Object with a certain color because of the object with the light wave with exact spectrum of the frequency corresponding with the particular color of the wave, the reflective of the surface of the strike on your eye that causes you to see the particular color. Color of an object therefore depends on the frequency of the electromagnetic wave reflected. Luminous body. With a certain body with the vast flame with electrical filament, light filament of various visible because of the light source. They are called the self-luminous body. The object of their self-luminous body becomes visible only when they're present with the light with a luminous body. Most non-luminous bodies are visible because of the diffuse of the reflective lights on them. The good example of non-luminous diffusing a body is the moon when shining on only because of the sunlight falls within the surface of the diffuse. Black objects do not view the reflect light. They are visible only when they outline again with the background light with a luminous diffusing body. Or properties of light. Light wave will travel a straight line with encountering something with either the transmitted, reflected, refracted, reflected, absorbed. The illustrated figure 119 light strike with the subsum of the absorption. Some of the reflection always takes place. No substance complete transmitted reflects absorb all the light wave to the reach of the surface. Those substances with the transmittance almost all the light wave will fall upon with the transparent. With the transparent substance is one of which we can see through. The clear glass, the transparent, because of the transmit light rays which diffuse them view with the VA with figure 120. Now you said, perfectly transparent substances must be substance as nearly show the substance through the such similar light rays can pass through the objects cannot be seen clearly because of the rays of the diffuse. The translucent view B of the figure 120, the frosted glass of the light bulb, piece of the oil paper are examples of translucent material substances that do not transmit light areas are called opaque. The view C of the 120 with the opaque substances can either reflect or absorb all light rays and fall upon them. Incident light rays, reflected rays, absorbed rays, transmitted rays, and also you have your transparent, translucent, oblique substances. Incident light, the transmitted light, incident transparent, translucent, incident light, transmitted light, incident light, light absorbed. Or the speed of light. You probably have heard of the people who quickly is lightning fast as light, fast as light, that describe the rapid motion, but nevertheless it is difficult to rely with how fast they actually travel the know. Not until the recent year that have scientists been able to measure accurately with the speed of light. Prior to the middle 17th century, the scientists thought that the light required no time at all to pass through the surface of the observer. And then in 1675, the Ole Romier, a Danish astronomer, discovered that the light traveled at approximately 186,000 miles per second in space. That the velocity the light beam can circle the Earth 7.5 times in 1 second. The speed of light depends on the medium through the light travel in the empty space with the speed of 1,860,000 miles per second. Almost the same in the air, and water slows down approximately 1,400,000 miles per second. Glass speed light with a 124,000 miles per second. In other words, speed of the light decreases the density of the substance through the light with the passage increases. Velocity of the light, which is same with the velocity of the electromagnetic wave, is considered to be constant 186,000 miles per second. They express the meters of 300 million meters per second. The reflection of the light waves obey the law of the reflection, same manner with the other type 2, but the conserve the straight path of light ray emitted with the narrow, still slightly darkened room. The straight path of the beam is made visible, illuminated on dust particles upon the air. The light beam is made to fall without the strip of the mirror with the other reflecting surfaces. However, the direction of the beam changes. Strip of the light can be reflected in almost direction depending on the angle of the which the mirror is held. It's shown in Figure 1.9 with the light beam striking the mirror with the angle of the beam that is reflected depending on the angle of the strike of the mirror. The beam approaching the mirror is called the incident, with the striking beam the beam leaving the mirror is called the reflected beam. Therefore, the term reflected light simply refers to the light wave neither transmitted nor observed but thrown back in the strip of the medium and encountered. Refraction of light, the change of the direction of the curve of the ray of light passes from one transistent substance into another different density. Either refraction is due to the fact that travel to various speeds of different transparent substance. For example, the water never appear with the deep as really is. Objects under the water appear to be closer to the surface than they really are. The bending of the light's waves are called their impressions. Another example of refraction of the apparent bending of the spoon with the immersion of the cup of the water with the bending of the same is to be take place within the surface of the water exactly at the bottom point of the where they change the density of the obviously the spoon does not bend with the pressure of the water. The light forming the image of the spoon is bent down the path of the water medium with the high density of the air with the medium with the comparative low density. Without refraction, light waves would pass with the straight lines without transparent substance without any of the direction. Refer to Figure 110, which show the refraction of the wave. As you can see, all the striking glass with any angle of the other perpendicular refraction. However, the perpendicular ray with the inch of the glass with the normal, the surface continues through the glass and into the air with a straight line with no refraction takes place. And diffusion of the light. When light reflected from the mirror with the angle of the reflection of each of the ray equals to the incandescence, the length of the reflected with the piece of the plain white paper. However, the reflected beam is scattered or diffused and is shown in Figure 121. The surface of the paper is not smooth, but the reflected area is broken up into many light beams and reflected in all directions. Diffusion of light. Or absorption of light. If you've seen the light has been reflected and diffused the fallen into pieces of the white paper that have been light beamed onto the piece of the black paper absorbs most of the light rays. Very little light reflected from the paper. The surface of the light beams fall within perfectly black. No reflection there is light within totally observed no matter what kind of space surface the light falls on. However, the sum of the kind of lights it is absorbed. All right, let's cut the tape.